Good morning, CP Pre-Calc. We are going to begin our last conic section for the year. So we're going to be talking about hyperbolas today. So first, let's start with the definition as we refer to it with conic sections. It's a hyperbola is a set of all points x and y all right, in a plane for which the absolute value of the difference the absolute value of the difference of the distances from two distinct points is constant. And guys, let me put this. Those two distinct points that we were talking about are the foci. All right. So what we have here is a diagram, and what they mean by what I just stated mean. If I picked a point on the hyperbola. So here's an example. Actually, we'll go through it. So this is an example of what we call a side-to-side hyperbola, and I'll explain what the definition up there meant when it talked about distance. So this is a side-to-side parabola because it opens to the side. Now, what you're going to have here is, in this case, it'll be slightly different. In the side-to-side hyperbola, we're going this way. It opens side to side. So we have like left and right. Let me just make sure. This is a side-to-side. And the equation for the side-to-side hyperbola is going to be x minus h squared. It's going to look familiar, but there's going to be one difference. Over a squared minus, and that's the key difference. There's going to be a minus, and it's going to be y minus k squared over b squared, and it's going to be equivalent to 1. So the big difference between the hyperbola's equation and the ellipse's equation is we have a minus as opposed to a plus. All right, guys. Now, we're going to just go over a couple of things. Now, when it talked about up top what the definition meant, it said a set of all points x, y in a plane for which the absolute value of the difference of the distances from two distinct points, the foci, is constant. Well, if we look at here, this is a foci 1, and this is foci 2. All right. Now we're going to talk about this. That's foci 1 and foci 2. What they're meaning is if I pick any point on this, let me try to get it on the hyperbola. If I have any point on the hyperbola, what they're saying is that point, if I take it, there's going to be a distance between foci 1 and that point and foci 2 and that point. So this is, say, D1, D2. What they're saying is no matter where that point is on the hyperbola, that the absolute value, if I subtract the two distances, it will always be constant. It will always be the same value. That's constant. So whatever that is, I shouldn't say it'll be, we'll just say is a constant, we'll say. No matter where that point is, I can move it anywhere on my hyperbola. That is what the definition is stating. Now we have parts of this, our hyperbola, so we're going to talk about it. We still have a center. So I'm gonna try to color code a little. The center is going to be right there in the middle of this X, and we're going to be drawing this X to help us out here. So in this case, this is my center. Okay, that's going to be your center of your hyperbola, and it's still going to be HK, which is nice. Nothing is changing there. Now, if I look at the vertices Okay, we're talking about our side to side now. So I'm looking at the vertices. Now your vertices here, I'm going to do that. Let's do a different color to make sure that let's see, I'm going to do a darker blue. Yeah, let's do a darker blue. These are my vertices. Let's get it like a big dot too. Those are my two vertices. So I have two vertices. I have vertice 1 and vertice 2. Okay. Now, how do we find your vertices? So we just said, if I look at vertice 1 and vertice 2, vertice 1 and vertice 2, how do we find the vertices? Your vertices will be, it's going to be H plus or minus K. I'm sorry, H plus or minus the A value, comma, K. And that'll give me two vertices because I'm going to add A and then I'm going to subtract A. Okay, now your foci. Okay, we already knew where I already labeled my foci. My foci, or the formula for the foci, is going to be H plus or minus C, comma, K. All right. Now, the other thing that we're going to talk about here, and when we take a look at this, is when we think about this, we have our foci, vertices, and all that. There's something else we're going to talk about. We're going to talk about a transverse axis. This is our transverse axis. I'm going to highlight it in green. This is my transverse axis. So it's going to be here. This will have it's in green, this will have a horizontal transverse axis. Now your transverse axis will always include, it'll be the axis that your vertices and your foci and your center are on. All those points, your center, vertices, and foci are all on that transverse axis, and that will help you determine which way it goes. All right. Now, the other thing I want to emphasize when we look at this is we'll have to talk about the distance of the boxes, but let's get the formulas down first, and then we'll go through a problem. All right. Now, if the foci here, I'll explain. The box is going to be interesting from the center. So let me actually label it here. If I look at this, we said the vertices are A. From the two vertices, from here to here, the length will be 2A. For a side-to-side hyperbola, 2A will go horizontally between the two vertices. Now, where does the 2B come in handy? Now, if I think of 2B will then be the distance, in this case, like the height of the box. So right here, if I looked at this, I'm going to highlight it in the orange too. This is 2B. That is 2B. And this here is 2A. All right, guys. The width is 2A of the horizontal, and the height is 2B of the horizontal side-to-side hyperbola. Okay. How will that change when I'm down here? So if I look at the up and down. So if I look at an up and down hyperbola, and I graph the up and down, it's going to look like this. It's going to go down to the vertice and up, and like that. And approach these asymptotes. So these diagonal lines that you see are asymptotes. So again, if I take a look at this, and let's just label some points right here, these are going to be my vertices. Okay, so this is V1 and V2. Those are my vertices. Okay, again, if I look at this, these are my foci. That dot, foci 1. Hold on, I drew the bottom one incorrectly. Foci 1. All right, sorry guys, I accidentally used the wrong point initially. So that's the vertices. So we got vertice 1 and vertice 2. And then I have foci 1 and foci 2. All right, guys. Now, how does the equation differ? Guys, the only difference is y is going to come first in that equation. So that's the big difference. A squared will always be first. And that is also a big difference. A squared is always first in the hyperbola. It doesn't move as opposed to the ellipse. So if we take, this is my up and down equation, guys. So if I look at that up and down, okay, the key is that y goes first. All right. Now, if we take a look at this, now your center's still in that same location. I can say in this case right here, this is my center. I'll put a big dot so we can see it. So right there, that is my center. That's the center, and that is HK. That purple is your center. And again, center is always HK. Excellent. The difference with the side to side now is it's going to have, let's see, if we talked about the vertices. If you looked at your vertices, you're still adding A, but you're not adding A to your X. You're adding A to your Y. So it's going to be H, K, plus or minus A. Those are my two vertices. If I look at my foci, again, I'm adding C, but I'm not adding C to my X. I'm adding C to my Y. So it's H comma K plus or minus C. All right, guys? There you go. Now you're going to have that vertical. Okay, we're going to say this, if I look here, it is going to have a vertical transverse axis. Remember, the transverse axis must contain the foci, the vertices, and the center of your hyperbola. Now, another big difference is the A value. The 2A will be the distance of between your two vertices. The 2B, so if I looked here, this here is my 2A of my box. Now, if I look here, if I do the other one, we said we did an orange. 2B will always be is perpendicular or the opposite. So that's our 2B. So if I look at this will be here, from here to here is 2B. All right. So 2B will not be the 2A will always go in the direction of your transversal axis. 2B will go perpendicular to it, that direction. All right, guys? So now what we're going to do is let's go through a problem. How do I use these two graphs is going to be the question. Let's go down. All right, guys, so let's continue what we're doing. Sorry, I had to take a break for a second. Now, the one thing I also want to make sure I emphasize back here, I just want to make sure in both cases, which I didn't write down, so can you guys please write down, thinking about it, I forgot to tell you how to calculate C squared. Now, be aware, C squared, it's a little different again. C squared is going to be equal to A squared plus B squared. So we're kind of going back to our Pythagorean theorem here. So in this case, C squared is equal to A squared plus B squared, and that is true for both cases. So whether it is a side to side or an up and down, we're going to say C squared is equivalent to A squared plus B squared. So we're looking at that Pythagorean theorem. All right. All right, guys. Are we good? So now let's take a look at, we're going to start to graph and just go over values. Now, here's our first thing. The first thing I want you to do is similar to what we did in the last problem with the ellipses, is first identify, do we have a side to side or do we have an up and down? And if we take a look at this, y is first. So I know if y is first, I have an up and down. So right now, off the bat, write that down first. I have an up and down. And that's important because it helps me look at the formula I need to use. So if I go to that up and down formula, it said y minus k squared over a squared minus x minus h squared over b squared is equivalent to 1. So that's the first thing. Now, let's go through what we need to identify. So the first thing I like to identify when we graph the hyperbola hyperbola, just like the ellipse and the circle and everything, is I like to identify the center. What is my center? And my center we know is HK. Well, in this case, in this problem, X and Y, nothing is subtracted from X or Y. So I would know my center HK would be 0, 0. All right, that's step one. That's the first thing that we're going to find. Now, the other things that we need to find is we need to know our A value and we need to know our B value. So let's see. If I took a look at that, if I look at this, A squared would equal 9. So I know A would be 3. B squared equals 16. So I know B is 4. And that is helpful. Now, how is that helpful? Well, what we're going to do once we do this is when we graph it, because that's our goal. When I graph this, my goal is the A and B help me identify how to make my box. All right, guys, it helps me make my box. How does it help me make my box? Well, A will always correspond with the direction in which I'm going. So I'm going up and down. That means I'm going to move 3 up. 1, 2, 3 up and 3 down. That's A. So I'm going to just put a point there and I'll pick a different color just to I'm going to go 3 up. Let me make it thicker so we can see it. I'm sorry, guys. 3 up and 3 down. So that's A. So what I did now is I identified both of this. This is A and A. Now, you know what direction to go based on if it's an up or down or a side to side. If it's up or down, A goes up and down. If it's side to side, A would go left and right. So that's A. Now let's look at our next one. Let's go back to black and we're saying B. B is 4. That means I go 4 to the side. 1, 2, 3, 4. 1, 2, 3, 4. So that B, would be 4 to the side. So here I have 2 B's, and if I count it over, this would be B, and this would be B. Now, make your box. Guys, make a rectangle. Use horizontal and vertical lines to make a box to help me graph my hyperbola. Count to the sides, and that's how we make the box to help us graph. Now, once we make the box, guys, what we can do once we make the box is to find the asymptotes of your hyperbola, we draw diagonals. Actually, let me do it let's do red. Diagonals through the center, because we already identified the center. So here's my center. We already identified it at 0, 0. You draw a diagonal through the center and opposite vertices of the box. So this here these are my diagonals. They're asymptotes to my hyperbola. All right, guys? I'm going to actually make them a little thinner for you guys. Sorry, guys. All right, so I'm going to make that a little thinner. So it's going to go through the edges of the box and the center. Those are the asymptotes of my hyperbola. Now I also have my center. So if I want to graph this hyperbola, I'm going to graph it in green. I also have my vertice. It's up and down. The A value on that box is your vertice, and we can label it. And if you remember, if we look at the vertice equation, it says the vertices, if it's A up and down, I'm going to add A to my K value and subtract it. So your vertices would be 0, 3, and 0, -3. Those are my vertices. Okay, now all I have to do, let's take a look what else we can state. Now I know it's an up and down, so I also know I have a vertical. We can state we have a vertical transverse axis. Excellent. And if we look at it, think about it. Remember I told you the axis has to contain the vertices in the center, but there's only one more thing I need to find out, my foci. Now remember, in order to find the foci formula, if I looked at it, your foci, we have to add C. So first find C. Remember, C squared equals a squared plus b squared. If I look at that, that means c squared would be equivalent to 9 plus 16, which is 25. So c would be 5. So with the foci, since it's an up and down, we add that c value to your k. So it would be 0, 5, 0, negative 5. So that would be my two foci. So I'd have, if I wanted to mark it, which you're going to need to know how to graph the foci. So just make sure that you're aware. I'd have foci 1, foci 2. And that would be my hyperbola. All right. All right, guys, let's take a look at our next one. All right, so let's take a look. Our center is slightly different in example 2. So let's take a look. I have to first identify if it's up or down or side to side. Now in the hyperbola, whatever variable comes first identifies that. So I know right off the bat, this is a side to side because x is first. Because x is first. So that's great. So now let's identify our center. Now your center is HK. So if I look at that, I have negative 1, 4 is my center. Now remember, A is always under the first term here. So that means in this case, I know A squared is 4. So A is 2. And I know B squared is 16. So B is 4. So that helps me right off the bat. We said identify that box. Now, first graph your center. Now that's key. This will be slightly different because I'm going to graph my center first. So my center is actually, let's get some points on here. Last was easy because I counted from the origin. And I counted from the origin because that was my center. But now I'm going to have to count from my center. So my center is negative 1, 1, 2, 3, 4. That's my center. That's HK. So that means I'm counting A and B from that value. Now this is side to side. That means I count A horizontally. So A would be what I count horizontally. So let's take a look at that. If I count A horizontally, I'm going 1, 2, 1, 2. So the distance between here, the center, and here on both sides is A. Now B, let's take a look at B. So I might have to add some, which I think I do. B is 4, right? Let's make this a little taller. Ooh. I just wanted to get rid of that. All right. Let's make this a little taller for me. Perfect. So now if I count B, let's do B a different color. I'll do purple. Now if I count B up, B is 4. So if I'm counting 4 up, I'm counting 4 from my center. 1, 2, 3, 4. 1, 2, 3, 4. All right, so I counted B from my center. So that means the distance between here is B. Make your box now. You can make that box, guys. Make a box. It's vertical and horizontal lines that go through your points. All right. Now, once you make the box, we can graph the asymptotes. The asymptotes are the diagonals that connect the vertices of the box and go through your center. Now, it's a side to side. Now, wherever that A is, we know the side to side, connect it from that A value. That's my vertices. So if I looked at my vertices, now it's side to side, we add A to X. So it would be negative 1 plus 2, which is 1, 4. Then negative 1 minus 2, which is negative 3, 4. We add A to our X to get the vertices. Excellent. We know we have a horizontal, transverse axis. All right. Because our center and our vertices go horizontally. Now, the only point I have left to identify is my foci. So now if I want to identify the foci, I'm going to do I look at my foci. I have to find C. So remember, C squared is equivalent to A squared plus B squared. Well, that means C squared is equivalent to 4 plus 16. So C is the square root of 20, which can be reduced to a perfect square factor of 20 would be 4. So it's 2 root 5. So it doesn't have to be exact. So we add this value to the x value of our center because it's a side to side. So it's your foci is going to be -1 plus 2 root 5, 4, and -1 minus 2 root 5, 4. These are my two foci, foci 1, foci 2. And guys, you can estimate where they are in your graph. So if you take a look and you want to estimate, it's -1, just put in your calculator. -1 plus 2 root 5 is approximately 3.47. So just estimate that distance. Well, estimate that point. So let's estimate that point. And if it says 1 to 3.5, so let's make that a little bigger. So 1, 2, 3, it's like about 3.5. So that would be foci 1. And then if I did my other one, that's foci 1, say. And then if I did my other one for foci 2, it would be -1 minus 2 root 5. And that would be -5.7. So if that's -5.7, I'm just going in the opposite direction. Let's say -5.7. 1, 2. 1, 2, 3, 4, 5.47. Yeah, 0.47. And that would be foci 2. And you would be done. All right, guys. Now for homework tonight, what you're going to do is identify the center of the hyperbola, the coordinates of the vertices, the coordinates of the foci, and you're not gonna have to write the equations here. We're not going to worry about that tonight. So what you're going to do is identify the center of the hyperbola, the coordinates of the vertices, the coordinates of the foci, and you are going to add this, guys. And for D, you're going to graph the hyperbola. All right, guys, and you're going to graph the hyperbola. So what we just did above, okay? And I would like you to complete problems 1, 2. Now, guys, if nothing's on the bottom, make a note. This is divided by 1 on each of them if nothing's below it. All right, guys? All right. And then the last one, I would like you to do 3 and then 4. So if you can do those 4 problems for me, that would be great. So you have 4 problems tonight for homework. If you have any questions, please come to office hours. I hope you guys had a great Memorial Day weekend, and I will talk to everyone soon.